This experiment will cover the sources of variation in error lab. First, you'll see our computer system. The program we use is called TWE Elite. Many of the programs have been pre-made and pre-stored into our program, so you can create saved tests that you want to run, but you can also create new programs or new tests that you want to create as part of a different experiment or a different test you want to run. So we go to File, Open Test, and in this case we want to open the Can Crush test. You'll see 3 black bars at the bottom, one that says load, one that says crosshead, and one that says strain. We're not measuring strain in this case, so there will be no value represented there. The main value we're looking at is the load, which you'll see right now reads about negative 24.89, and we'll be zeroing that value out when we run our test. As part of the system, we have the controller that monitors our MTS machine, and from this we have the lock/unlock button. This can also be shown at the top of the computer screen. When you press it and it is unlocked and you're able to manipulate the MTS machine, it'll turn into a symbol that looks like the controller, and then you'll be able to use the up and down arrows to more quickly move the locations for your load cell point. And then when it's locked, it'll look like your play pause and you'll be ready to run your test. The black dial that I was moving was the fine tuner, and in that case you're just moving your system at a slower pace, up or down. So from this we can obtain our can. And we can check out our can before we place it in. We can see if there's any kind of dent or imperfection in it, anything we want to note that is of variability to, say, our specimen. We want to place it into the center of our clamped location, so our bottom plate, and then we want to move our top plate down to about, say, 1 centimeter above our can in order to quickly be able to run our test. Once we place our can and we have that ready, we can zero out our load, and by doing this we will right click on that black box and hit zero signal, and that will zero out our specimen for our test. So now we can lock our system with the controller and we can run or play our experiment. So once we press play, it'll take a second, and then we get a dialog box that comes up, and it'll ask us to confirm or adjust our dimensions for our experiment. So since this test was made for our Can Crush experiment, we just press enter here. It just has the dimensions of our cans as our approximate value. So now you'll see the top section of our system slowly lowering onto the can, and then you'll see the cans be crushed. In this case too, we're also not looking for a completely flattened can. We're looking for the peak load that can be adjusted for that can. So we're not looking for, say, a completely flat specimen. We're looking for that peak load that can be applied to the can. Once you see that peak point on your graph and it's kind of leveling out or decreasing in the load, you can stop your test, or the computer system can stop your test when it realizes it's reached its lowest point. Either of those cases are fine, and you can then obtain your peak load, which is in that third column, and in this case it is 91.983 pounds. So now we can take the can, we can see the locations that it's been crushed at, and then we can place that can aside and test another specimen. So there'll be about 10 cans tested in this particular video. I didn't test all 64 in the video, so you wouldn't have to watch all of them, or in any case I didn't film every single can that we'll be testing, but we have about 10 cans that will be tested in this video, and you'll be able to see the process for various manufactured cans or brands in terms of what their crush load availability is.